What if the next great explorer of Mars is not a human astronaut, but an artificial intelligence system? Today, space exploration is entering a completely new era. We are no longer only sending rockets, satellites, and rovers into space. We are sending intelligent machines that can see, decide, learn, and adapt. In this video, we will explore how artificial intelligence is helping humanity discover the Moon, Mars, and deep space. From autonomous rovers to scientific discovery, from astronaut support to mission planning, AI is becoming one of the most powerful partners in our journey beyond Earth. So let's begin our journey into the future of space exploration. Space is beautiful, but it is also extremely dangerous. When we explore beyond Earth, we face long communication delays, unknown terrain, extreme radiation, limited energy, and mission conditions that can change very quickly. For example, when a rover is moving on Mars, it cannot always wait for instructions from Earth. A command may take several minutes to arrive. In that time, the rover may face rocks, slopes, sand traps, or unexpected obstacles. This is why AI is so important. AI allows spacecraft, robots, and satellites to make smarter decisions by themselves. It helps missions become faster, safer, and more efficient. In short, AI gives space missions something very powerful: autonomy. AI is not used for only one task in space. It is used across the entire mission. First, AI helps machines see. Computer vision allows rovers and satellites to analyze images and identify rocks, craters, ice, dust storms, and landing sites. Second, AI helps robots move. Autonomous navigation allows rovers to plan safe paths across difficult planetary surfaces. Third, AI helps scientists. Machine learning can search huge datasets and identify patterns that humans may miss. AI is also used for mission planning, predictive maintenance, and astronaut support. So when we talk about AI in space, we are not talking about one technology. We are talking about an intelligent system that supports almost every stage of exploration. Imagine a rover driving across Mars. There are no roads, no GPS, no rescue team, and no repair shop. Every movement must be carefully planned. AI helps the rover look at camera images, build a map of the terrain, detect hazards, and choose the safest path forward. Instead of blindly following fixed commands, an AI-powered rover can evaluate the environment and make decisions. Should it go left? Should it avoid a rock? Should it stop because the slope is too steep? This makes Mars exploration much more efficient. AI turns a rover from a remote-controlled vehicle into a semi-independent explorer. Before humans can land on the Moon or Mars, we need maps. But planetary surfaces are enormous. Satellites and orbiters collect thousands or even millions of images. It is impossible for humans to manually analyze everything quickly. AI can help by transforming raw images into useful maps. It can identify craters, detect minerals, classify surface materials, and highlight safe or dangerous regions. For future missions, AI-based mapping can help answer important questions. Where should we land? Where might water ice exist? Where can astronauts build a base? In this way, AI becomes the eye of planetary exploration. One of the most exciting uses of AI in space is scientific discovery. Space missions generate huge amounts of data. Images, spectra, temperature measurements, radiation data, atmospheric data, and geological information all arrive from distant worlds. AI can analyze these datasets quickly and help scientists find the most promising targets. For example, AI can help identify unusual rocks, possible signs of past water, or chemical patterns that deserve further investigation. This does not replace scientists. Instead, it helps scientists focus their attention on the most important discoveries. AI acts like a scientific assistant, searching through massive data and saying, "This part looks interesting. Please investigate further." A space mission is like a giant puzzle. Every day, mission teams must decide where the rover should go, what instruments should be used, how much energy can be spent, and how to avoid risks. AI can support this planning process. It can optimize schedules, evaluate different routes, manage energy, and adjust mission plans when unexpected situations occur. This is especially important for missions far from Earth, where communication delay becomes longer and real-time control becomes impossible. The farther we go into space, the more autonomy we need. AI helps missions become more flexible, more intelligent, and more resilient. AI is not only useful for robots, it can also support astronauts. In future Moon and Mars missions, astronauts will live in isolated, high-risk environments. They will need help with health monitoring, equipment checks, navigation, scientific tasks, and emergency response. AI assistants can monitor astronaut health, detect stress or fatigue, manage spacecraft systems, and provide real-time decision support. Imagine an astronaut working on the Moon. If a system warning appears, AI can quickly analyze the problem and suggest a solution. This kind of support can reduce workload and improve safety. In deep space, AI may become an essential member of the crew. In space, equipment failure can be mission-ending. A small problem in a rover, satellite, or spacecraft can become a serious risk because repair is extremely difficult. AI helps by predicting problems before they happen. By analyzing sensor data, temperature changes, vibration, battery performance, and mechanical behavior, AI can detect early warning signs of failure. This is called predictive maintenance. Instead of waiting for a system to break, AI can help mission teams take action early. For long-duration missions, this is extremely valuable. AI can help protect spacecraft, extend mission life, and reduce the risk of unexpected failure. The future of AI in space is even more exciting. On the Moon, AI can help support autonomous robots that build infrastructure, search for resources, and prepare bases for humans. On Mars, AI can guide rovers, drones, and future habitats. In deep space, AI may help spacecraft explore moons, asteroids, and planets with very limited human control. As missions become more distant and more complex, AI will become increasingly important. We are moving toward a future where space missions are not only controlled from Earth. They will be intelligent, adaptive, and capable of making decisions far away from home. Now let's look at the technologies behind this revolution. Computer vision helps machines understand images. Machine learning helps AI recognize patterns and data. Reinforcement learning allows robots to learn better actions through trial and feedback. Generative AI can support mission design, simulation, and data interpretation. Physics-informed AI combines machine learning with scientific laws, making predictions more reliable for engineering and space systems. These methods work together to create intelligent exploration systems. The real power of AI in space comes not from one algorithm, but from combining many intelligent techniques into one mission workflow. A digital twin is a virtual copy of a real system. In space exploration, we can create digital twins of rovers, spacecraft, habitats, or even entire mission environments. Before sending a rover to Mars, we can simulate its movement, energy consumption, risks, and scientific tasks in a virtual world. AI can use this digital twin to test thousands of mission scenarios. What happens if the terrain is rough? What happens if energy is limited? What happens if a dust storm occurs? By testing these possibilities before the real mission, AI helps improve safety and performance. Digital twins allow us to fail safely in simulation before succeeding in space. Autonomous navigation is one of the most important abilities for future space robots. A rover must understand its environment, identify obstacles, plan a safe route, and adapt when the terrain changes. AI helps the rover combine camera data, terrain mapping, hazard detection, and path optimization. The goal is simple but difficult: move from one point to another without getting stuck, damaged, or lost. This is especially important on the Moon and Mars, where surfaces may include craters, rocks, steep slopes, and loose soil. AI navigation gives robots the ability to explore more confidently and more independently. The Moon is becoming a major target for future exploration. AI can support lunar missions in many ways. It can help map resources, such as possible water ice in permanently shadowed regions. It can guide rovers through rough lunar terrain. It can assist with autonomous construction, surface operations, and scientific sampling. The Moon may also become a training ground for Mars missions. Before we send humans deeper into space, we can use the Moon to test AI-powered robotics, autonomous habitats, and intelligent mission systems. AI will help turn the Moon from a destination into a working platform for future space exploration. Deep space missions face one major challenge: distance. The farther a spacecraft travels, the harder it becomes to control from Earth in real time. For missions to asteroids, outer planets, or distant moons, AI must help spacecraft make decisions independently. AI can manage navigation, detect anomalies, prioritize scientific observations, and adjust mission plans. This is not just convenient. It is necessary. In deep space, waiting for instructions from Earth may be too slow. AI allows spacecraft to respond immediately to new conditions. The farther the mission goes, the more important autonomy becomes. AI is powerful, but it is not perfect. In space missions, mistakes can be extremely costly. AI systems may face uncertainty, incomplete data, sensor errors, unexpected environments, or situations they were not trained to handle. There are also important questions about trust. How much decision-making should we give to AI? How do we verify that AI decisions are safe? How do we explain AI behavior when something goes wrong? This is why AI in space must be accurate, reliable, explainable, and human-supervised. The goal is not blind automation. The goal is safe intelligence. A common fear is that AI will replace humans. But in space exploration, the better vision is partnership. Humans bring curiosity, creativity, judgment, and scientific imagination. AI brings speed, pattern recognition, automation, and the ability to process massive amounts of data. Together, humans and AI can do more than either could do alone. Astronauts can focus on high-level decisions, scientific interpretation, and exploration goals, while AI handles repetitive analysis, monitoring, and operational support. The future of space exploration is not human versus AI. The future is human-AI collaboration. Let's imagine a complete AI-powered mission workflow. First, the spacecraft observes the environment using cameras and sensors. Second, AI analyzes the data and identifies important features. Third, the system prioritizes scientific targets. Fourth, AI plans a safe path or mission action. Fifth, the robot acts, collects data, and continues exploration. Finally, the AI learns from the results and improves future decisions. This creates a continuous loop: observe, analyze, prioritize, plan, act, and learn. This workflow is what makes future missions more intelligent. It allows exploration to become faster, safer, and more adaptive. Let's summarize the most important ideas. AI enables autonomy. This means rovers, satellites, and spacecraft can make decisions with less dependence on Earth. AI improves navigation by helping robots avoid hazards and move safely. AI accelerates discovery by analyzing huge scientific datasets. AI supports astronauts by monitoring health, systems, and mission conditions. But AI also needs safety, testing, verification, and human oversight. The main message is clear: AI is becoming the intelligent partner of future space missions. It will help humanity explore places that are too far, too dangerous, or too complex to explore by traditional methods alone. The universe is vast, but with artificial intelligence, our ability to explore it is becoming greater than ever. See you in the next video.